Welcome back students. In this video we are doing the previous year questions based on what? Rotational motion. Okay, let's start. First problem says that if a straight light of mass m is suspended from the end of a uniform rod of length L in the different possible patterns as shown in figure, which is more sturdy pattern, which is what? More rigid or strong. So look here, this is your pole and this is your like tube light or something. You want to support this, so they say, should I support it at the end like this one, this is your string, or I should support at this point or that point. Some points are given. So you know that this is a tube light. Look at this point, this is your tube light. Okay, it has some weight always act through what? Center of mass. I am here, correct. You want to hold this stationary, which is easier, better pattern. This will rotate about that point, right? Suppose you break the string, it will rotate about what? That point. We want torque. Suppose there some torque is required to hold this. The torque is what? You know, force into what? Perpendicular distance, or perpendicular distance into force, right? Yeah. So what I am saying, look here, you want to make this force minimum. If you want to make force minimum, then your distance, perpendicular distance should be what? Maximum. Suppose you tie your string here, right? The distance is what? Very small, right? Perpendicular distance is what? Very small. The force exerted on this pole due to this, the weight of this what do you say, tube light will be what? Very high. So we want to reduce that what? Force you want to make minimum, so distance you should make it what? Maximum. So this way, like when you tied your string at the top, then you know this distance is what? Maximum in this case, right? R is maximum, so force will be what? Minimum in this case. That will be more sturdy or strong pattern. So what is the answer of this question? First question, first option. Okay, yes, okay, that's what your first question. Yes. Second problem, a uniform rod AB of length L and mass m is free to rotate about end A. The rod is released from rest in the horizontal position. Given the angular momentum about A is what? ml square by 3. The initial angular acceleration of the rod is what? A simple problem is given. They say there is a rod is there and this rod can rotate about this end, right? In this horizontal positions. If we leave this will become vertical or start rotating like that way. So they are asking what is the initial angular acceleration, right now? Yes. So this rotating because some torque is acting, and what is torque? Due to the force or you say weight of this rod mg, right? Weight acts through the center of mass of this rod, middle point. Okay, that length is given total as L. So that distance will be what? Your L by 2, obviously, right? So what is torque produced due to this weight? So torque will be simply say that force into perpendicular distance. So mg is what? Mg, force is what? Your mg, and that perpendicular distance is what? L by 2. This is a torque produced, right, by the weight of this rod. So torque is also equal to what? I into alpha, we know, right now, I into alpha, right? So inertia, this rod is rotating about end of the rod, right? So let's write mg L by 2. What will be inertia at the end of the rod? ml square by 3, already we know, and the given equation itself, and we have to calculate angular acceleration. So let's cancel, m goes here, 1 L goes here. So what is remaining? Alpha, you see, is become 3 by 2 g by what? L. That's what your angular acceleration. Suppose they ask linear acceleration of any point here, like this point, that point, then angular acceleration into radius, that's called what? Your linear acceleration. So linear acceleration will vary. Angular acceleration, suppose any point they ask here, like this point, that point, that point, angular acceleration will be same, but linear will be different. When linear depends upon what? Radius. Suppose they ask linear acceleration, you write what? Radius into what? Your angular acceleration alpha. So they can ask about this point, that point, any point, it will be different. So you can answer from what? Here. Okay. Okay. So the answer of this question is what? First option itself, right? Okay. Moving to next problem, which is problem number 3, and they said here 4 identical thin rods of each mass m and length L forms a square frame. The moment of inertia of this frame about an axis through the center of the square and perpendicular to the plane is what? So 4 simple rods are given, thin rod. They are arranged to make like a square frame, like this way. These are the 4 rods. They are asking what is the moment of inertia of these 4 rods about this axis. The axis is passing through the center of mass and perpendicular to the plane, right? So it's very simple. We have to find inertia about that point, right now. Correct. So we will use parallel axis theorem. Let's find inertia first due to any one rod. Then we have 4 similar rods at same distance. So first we need that distance. Suppose length of the rod is given L. You know that distance become what? L by 2. We know inertia about the center of mass of a rod, right? How much? ml square by 12. So we use parallel axis theorem, thus your distance d only. We know inertia about this point, that's called what? Center of mass of the rod, and we want to find inertia about that point, so we use what? Parallel axis theorem. So inertia of any rod becomes what? I is what? ICM plus what? MD square. ICM is what? ML square by 12, mass is m, and d means that distance, right? It's rotating about what? That point. The axis which passing through center of mass is what? Here we know is answer is what? ML square by 12. We want to point at that point, so we are writing parallel axis theorem. D square means L square by 4, so this become ML square by what? 3, correct na? Okay, this is the inertia due to what? Any one rod, and we have exactly similar four rods, right? So same means we can directly, final answer we can multiply this as what? 4 times, that's your answer. Okay, yes, because 4 similar rod at the same distance, everything is same, so we are directly writing 4 times of that, so answer becomes here second option is the correct answer. Okay, moving on to problem number 4. It says if force is acting on a particle having position vector r and t is the torque of this force about the origin, then which is the correct statement? So talking, we know torque is nothing but what? R cross what? F, right? This is the correct formula first. So I already told you many times, 3 vectors are multiplied by cross product, and you take dot product of any 2, it always becomes what? 0. So that question is only here. So they are saying like first option, R into torque is 0, yes 0, F into torque is not 0, no, everything will become 0. If you take any multiplication of these 3 things in dot product, answer becomes what? 0. So what is correct answer in fourth option? Fourth question, fourth option is the correct answer. They wrote fourth option that R cross torque 0, force dot torque is 0, anything you take, any 2 of them at dot product, answer becomes what? 0. This is applicable to what? Any type of things, any vector which are like multiplied by cross product, 3 vectors and these are multiplied by cross product, answer becomes what? 0 if you take dot product of any of them. Fifth problem. So here answer is what? Fourth option. Fifth, they said a thin circular ring of mass m and radius r is rotating in a, okay, actually some of the students have asked that they don't receive these sheets, so please they said that mention the year in which these questions were asked, right now? Yes, so I will try to do that. So let me write, the first question was asked in AIMS, okay, 2006, okay, and second question was asked in AIPMT, means your NEET exam, it used to call 2007, okay, and question number 3 was AIPMT 2000, okay. This is from again NEET or you say AIPMT 2009, and the fourth question that I have done, that's from also 2009, okay, and the fifth question I am doing is from what? 2010 AIPMT. We have question, I am doing questions either from AIMS or what? NEET, means AIPMT, these 2 only, okay. Okay, so we are talking about 210 question, and it says a thin circular ring of mass m and radius r is rotating in horizontal plane about an axis vertical to its plane with a constant angular velocity omega. So ring was there, we had a ring of radius r, mass m, rotating with angular velocity omega about that axis, okay, yes. So this is the initial situation. Then what we did, 2 objects of each mass small m is attached gently to the opposite end of a diameter of the ring. Then what we do, 2 mass are placed here, 1 mass here, 1 mass here, small m value, okay, point mass is, okay, yes. And now they are asking the ring will rotate with angular velocity of what? Initial is omega, what is new angular velocity? So this is a question based on what? Conservation of angular momentum, right? We are generally attaching here, so angular momentum should be always conserved. So what is initial angular momentum? Let's write initial angular momentum is what? I omega we are writing. So what is initial inertia? This is a ring given, right? Be careful, circular ring. Okay, so what is the inertia of the ring? Ring is rotating about that axis, right? An axis passing through center of mass and perpendicular to the plane. So answer becomes what? M r square, correct. Initial angular velocity is given what? Omega. This is the first, initial your angular momentum. Let's find final angular momentum. Okay, so angular momentum of the disc will ring will be same, m r square plus the inertia of these 2 point masses will come, 1 mass here, 1 mass here. They place a distance of what? R, right? Place at the on the ring and diametrically opposite the side. Okay, so inertia of this becomes m r square, inertia of that becomes what, m r square, general formula writing for point masses into some angular velocity, new angular velocity omega days we calling. So this initial angular momentum should be equal to final. So when you do like this one, you will get m r square divided by this, that become m r square plus 2 times of small m r square into what, omega, that becomes your omega days. We are just equating them. So here if you want to cancel r square terms, you can cancel. So m upon m plus 2m into what, omega, that answer comes, and which is given in what, your third option. Okay, so third option is your correct answer for this question. So question number 6 we are doing. So this is from AIPMT 2011. Okay, yes. So it says that the instant angular position of a point on a rotating wheel is given by. So angular displacement is given as function of time. They said 2t power 3 minus 6t square. This is given to you. Okay, yes. Angular displacement is given as a function of time. Okay, so they say that the torque on the wheel becomes 0 at what time? They said torque becomes 0. What is torque formula? We wrote somewhere here. Torque is what, in terms of force, this you can also write what, I into alpha. You know that if mass is there, then inertia cannot be 0. So torque will become 0 when what, angular acceleration is what, 0, right? Torque formula is what, I into alpha. Inertia cannot be 0, right now, or is rotating at some distance means inertia cannot be 0. So torque directly depends on what, alpha, right now, angular acceleration. So when angular acceleration becomes 0, then torque will become 0. So let's find angular acceleration. This is a displacement equation given. We can find velocity, we can find acceleration by differentiating it. So let's differentiate this equation. First you get what, velocity, angular velocity. What is the answer? This becomes 6t square minus what, 12t. That's what your angular velocity. Again differentiate this to get acceleration. So become 12t minus what, 12. And they said that torque becomes 0. So alpha should be 0. So equate it 0. Time will get what, simply 1 second. 12t is equal to 12. So 1 second, that is the time after which the torque on this body becomes what, 0. Correct? Okay. Moving on to problem number 7. So this is also from 2011, AIPMT 2011, same only. Okay. The moment of inertia of a thin uniform rod of mass m and length L about an axis passing through the midpoint and perpendicular to length is what, I naught. Again the rod question they are asking, simple problem. They are saying the inertia about this point. What point? An axis passing through the midpoint and perpendicular to the length, means about that. So this is given I naught, and you already know that is what, actually ml square by 12 we know. So this is given what, I naught symbol to us. Okay, yes. Then what they are saying is moment of inertia about an axis passing through the one of the end and perpendicular planes. So simple question they are asking there, what is the inertia about what, this point, right? Already you know it's ml square by 3 if you put the value, but they are asking in terms of this symbol. So just be writing parallel axis theorem. Inertia about that point will be inertia about center of mass. They are writing I naught symbol plus md square. Md means that distance, that's what, L by 2. So become L square by 4. This much only they are asking done. Okay, yes. So here second option is the correct answer. This was the 2011 problems. Okay, there is one more 2011 problem. So next problem is also 2011, 8th problem. Okay, 3 questions were asked. Okay, a small mass attached to a string rotate in a frictionless tabletop as shown in the figure. So some mass is attached to a string, this M, and rotating in a circle on a table. If the tension in the string is increased by pulling the string, causing the radius of the circular motion to decrease by a factor of 2. So say initial radius is r, now we are pulling this, so that radius becomes what, r by 2, radius is reduced. Okay. Then they are saying that what happened to kinetic energy. So when you are doing this, what not changing, again you are writing like momentum will remains constant, angular momentum will remains constant. They are saying when I am changing radius, what happened to what, kinetic energy. So kinetic energy formula is what, half I omega square, right now, but we don't know omega in these things. So we write in terms of directly angular momentum. So kinetic energy in terms of angular momentum is what, L square upon what, 2I, right? This is the formula, simple. You can ask me why I am not writing this formula, that kinetic energy is what, half I omega square. Yes, you can write, but here what's the problem? Here inertia also varies because radius varies, so inertia is what, mr square, that varies. Then angular velocity will also vary, so we don't know angular velocity right now, but we know that when we do this one, momentum is always conserved, angular momentum is always conserved. So instead of writing this, you directly write this formula, because this is a constant, then only inertia is variable, right now. So inertia we know because radius we know. So look here, I am writing here L square to inertia will be what, mr square, right. So these are constant, these only what is variable, r square. So energy in this case will be inversely proportional to what, radius. Initial energy is given E, new energy we have to calculate E days. So initial radius given r square, new radius given r by 2 square. So this become 1 by 4. So you see that E days becomes what, 4 times of the. So kinetic energy will be increased by what, 4 times. So this is given in fourth option. Okay. Okay. Then we are doing problem number 9, and this is from AIPMT 2012 now. 11 we have done 3 problems. So now we are doing from what, 2012. So ABC is an equilateral triangle with OS is center, F1, F2 and F3. These represent 3 forces acting along the sides AB, BC and AC. If the total torque about point O is 0, then the magnitude of F3 should be what? Very simple question actually. So look here. They said 3 forces are acting, they shown in terms of triangle. So how? This is the direction of your F1 force acting here, and this direction of your F2 force here, and F3 is along this line. This is your F3, correct. So they are saying how these F1, F2 and F3 are related, and they are saying there is some point given, this point O, and they are saying about this point O the net torque is given what, 0. So this is first understand the equilateral triangle. So everybody has same distance from here, right? Correct. So suppose you write net torque here, then what you write, like F1 into that distance, perpendicular distance. It's like, okay, let me take you. Net torque is already given 0. You write torque due to this force. You said F1 into perpendicular distance, let's call that x, whatever, into x. Correct. Okay. Then this force F2 into what, for this also the distance will be what, that was also what, x. Okay, that is what in opposite direction, that force. These are like trying to rotate like in one direction, that's what in opposite direction, that you can write minus F3 into what, again distance will be what, x, all equal to 0. So simply you see the F3 becomes what, in vector you should write, because they are asking answer in terms of vector form now. Okay, magnitude only they are talking, so it's okay. So simply it becomes what, F1 plus what, F2, that's your answer. Or if you don't want to use this rule, then we have learned that our this vector addition of triangle law of vector addition, that if 2 sides taken in same order, then third side taken in opposite order gives sums of the first 2, right now. Triangle addition rule what says, 2 sides taken in same order like clockwise, then third side taken in opposite order gives sums of first. This is side A, that's B, that's C, then C is simply equal to what, vector A plus what, vector B, like that. Okay, yes. So net torque is already given 0, so this relation comes. Okay. So next question, question number 10, also from AIPMT 2012. When a mass is rotating in a plane about a fixed point, its angular momentum is directed along. So when a mass is rotating in a plane, means like on board, torque direction they are asking. Torque formula is what? We learned is R cross what, F. Right now, somebody is moving a plane, then what is the direction? Already I told you, still I am telling, look here. So this is what direction of suppose force here, right, like your centripetal force. That's the direction of what your what? So let me read the questions once more. Yes, correct only, nothing wrong. Okay, so what I am trying to say, look, these two vectors are perpendicular to each other, then this also again perpendicular to both of them. Suppose this is what in x, I direction, this is in j direction, that becomes what, k direction. So it's rotating in a plane means what, x, y plane they are rotating, right now, this x and what, y, right. So your distance and force are in x, y plane, then your torque should be what, in z direction always, right. When anybody rotate in a plane, then the angular momentum will be always perpendicular to what, that plane, correct now. So always perpendicular to the plane. So question number 10, what is the answer? Third option should be correct, a line perpendicular to the plane of rotation. Okay, always these 3 things are always perpendicular to each other, keep in mind. Okay, yes, that was question number 10. Question number 11 also from AIPMT 2012, and it says that A solid cylinder of mass 3 kg is rolling on a horizontal surface with a velocity of 4 meter per second. It collides with a horizontal spring of spring constant 200 Newton per meter. The maximum compression produced in this spring is given by what? So in last chapter I told you, what I told you, whenever they ask maximum compression spring, you have to talk about what? Energy concept, right? So cylinder was rolling, it's what rolling right now? Yes, rolling is given, it hit a spring, the spring will compress, they are asking what's the maximum compression of the spring. So energy from this cylinder goes into the compression of the spring. So energy stored in spring becomes what? Half kx square, which is coming from what? Energy of the cylinder. So this is rolling, so you have to write what? It's rolling kinetic energy, okay? Let me write kinetic energy of what? Rolling, right? Okay, so let's do calculations. Half kx square is equal to what's kinetic energy of rolling? You know, half mv square plus half I omega square, right? Translated plus rotation. So for this also I told you, you can directly write this one, half kx square, you can write half mv square plus half k square by r square, right? Yeah. Because here linear velocity we know, so we are writing this format. Suppose you know angular velocity, you can convert this into angular format. Okay, so here we know linear. So all values are given, let's cancel plus half. So let's write kx square plus how much mass given? Mass is given as what? 3 kg into velocity is given as 4 meter, 4 into 4, 1 plus k. We need k. What is k? This is what? Solid cylinder given. Solid cylinder inertia is what? mr square by 2. So I told you what is k square we need here. K square means what? Living mass, that term is simply k square, or you write your formula if you want to write I by m, right? So when you put here what? r square by 2 by r square. Okay, so this become kx square is equal to what? 3 into what? 16 into this become 1 by 2 means this become 3 by what? 2. Okay, yes, 1 plus 1 by 2 means what? 3 by 2. And now we need what? We need x. So x will be equal to actually 9 into this becomes what? 8 by k. How much k given? K is given 200 all under the root, right? Okay, let's simplify this. So 8 goes what? How many times? We cancel for 25 times, right? 25. So this remains root 9 by 25, that becomes 3 by what? 5. So how options are given? Yeah, 3 by 5 is 0.6 meter is the answer given. That's the answer of your question number what? 11. Okay. Simple conservation of energy principle writing. Energy in the cylinder goes to what? Energy stored in the spring. Okay. Okay. Question number 12 is from AIPMT 2012. The moment of inertia of a uniform circular disc is maximum about an axis perpendicular to the disc and passing through the point. A disc they have shown, this is a disc, and few points they have mentioned on this. They are asking about what point the inertia will be maximum. So one point is what? Center of this, A point, one point the rod here, D point, one point they have mentioned what? I think this is little looking little away from this, C point. And one point they have mentioned is what? B point. They are saying about what point the inertia will be maximum for an axis which is perpendicular to the plane of this disc. So look, we know that inertia at, always remember that inertia about center of mass, inertia about center of mass is always minimum. The minimum value of center of mass happens where? The minimum value of moment of inertia is always about what point? About its center of mass. When you are moving the axis of rotation away from the center of mass, the moment of inertia will be increasing, because you know our theorem says that inertia about any point is about ICM, means moment of inertia about center of mass plus md square. When this d is increasing, distance, inertia will be increasing. So you see that among these 4 points, your B point is what? At maximum distance. So inertia at this point will be maximum and inertia at point A will be what? Minimum. So here they are asking about what point the inertia is what? Maximum. So B point, about this point will be your answer, right? B point, which is given in what? Third option. Okay, yes. Problem number 13 we are doing now, and it says a circular platform is mounted on a frictionless vertical axle. Its radius is given 2 meters. Moment of inertia about axle is given, and it is initially at rest. A 50 kg man stands on the edge of the platform and began to walk along the edge at the speed of 1 meter per second relative to the ground. The time taken by man to complete 1 revolution is what? Okay. This question is from 2012, again AIPMT. Okay, look here. They said there is a circular platform is like this given and radius given 2 meter, and main is standing here on the edge here. Initially the main and the disc both are at rest. Okay, yes. Now the main start walking in any one direction. Suppose you walk clockwise with angular velocity omega 1, you know that disc will rotate in upward opposite direction with angular velocity omega 2, right? No, yes, main start walking. So few things are given to you. Inertia of the disc is given directly, that's given 200 kg and meter square. Mass of the main given 50 kg, radius given, then velocity of this main also given 1 meter per second, right? And this is given relative to ground, be careful. So they are asking what is time taken by main to complete one revolution. Time you want to find means always need what? Angular velocity simply. So look here, first give attention. Because this main and this platform are one system, there is no external torque acting. So the angular momentum will be conserved. Means initial angular momentum will be equal to simply final angular momentum. What is initial angular momentum? Angular momentum of main plus angular momentum of disc, both are what? 0, 0, both are at rest. So initial angular momentum is what? 0. Final should be also what? 0. So let's write final momentum. Final angular momentum will be what? Angular momentum of main plus angular momentum of disc. What's angular momentum of main? What is angular momentum formula? I into omega, right? Inertia into angular velocity, right? So give attention. What's the inertia of the main? Main is a point object for the system. So inertia will be mr square. Mass of the main given 50. R square means radius given how much? 2 meter or something else? No, it's given actually. Yeah, 2 meter only given, right? So 2 become 4 mr square, or let me write 2 square is mr square, inertia, angular velocity. So that we can find because linear velocity is given to us. Look here, this is a linear given. So angular will be omega will be v by r simply. V is 1, r is given 2. So this becomes simply 1 by 2 radian per second square, sorry, per second. So you can put here angular velocity of the main we know, plus now angular momentum of the disc which is given 200, angular velocity we have to find. So this is a final momentum should be equal to what? Initial momentum what? 0, correct? So if you watch carefully, so yeah, this become what? 200 goes that side, cancel, then omega 2 will simply comes what? Minus 1 by 2. This is the angular velocity of disc is coming negative, yes, because main working clockwise, then disc will rotate in what? Opposite direction or opposite sense, right? Correct only. Now give attention here that relative velocity, this was given with respect to what? Ground. So we need relative velocity of the main with respect to what? Disc. So relative velocity of main with respect to disc, md, velocity of the main minus velocity of the disc. So velocity of the main is what? 1 by 2 minus velocity of disc also came what? Minus 1 by 2. This becomes simply 1 radian per second square. Okay, so we need time. So we know omega is also equal to what? 2 pi by t. We need time, that becomes 2 pi by omega. Omega is coming what? 1. So time becomes just 2 pi second. That's all. Yes, little difficult, not too much. Consideration of momentum we writing, and the concept of relative velocity will came that we should learn in motion chapter. That topic I will teaching you very soon. Okay. Yes. Let's move to the next question. Question number 14. 2014 AIPMT 2014 problem, and it says that a solid cylinder of mass 50 kg and radius 0.5, cylinder is given, solid cylinder, mass given, radius given, is free to rotate about the horizontal axis. A mass-laden string is wound over the cylinder and one end is attached overhanging. So simply saying that this is solid cylinder and some string is wound over this and is what? Like this way. So when you pull this string, we know that the cylinder start rotating, right? We are applying a force F, or you can say simply tension this string T. That's what your perpendicular distance what R, right? Simply question about torque. So they said the tension string is required to produce an acceleration of what? 2 revolutions per second square is what? So look here. So what is the torque about that point? When we apply a force here, we pull that string, you know, that cylinder or disc, whatever this object, it start rotating. So what is the torque produced by this force? So force is what? Tension T, or force applied here, like sometime mass hang is given, then become mg into perpendicular distance become radius r. So this is what? Torque. That should be equal to what? I into what? Alpha. They are asking us how much tension or force we need. So tension will be simply equal to what? I alpha by what? R. Let's calculate. First we need inertia. Inertia is not given, so let's write inertia is what? Inertia of solid cylinder become mr square by 2, and all values are given. How much mass given? Mass is given what? 50 kg. Radius given what? 0.5 is 1 by 2 into what? 1 by 2, 1 more 2, so this has become 50 by what? 8. This is your inertia. Okay, inertia done. Then you need what? Angular velocity, right? So angular, what they gave? So give attention here, very important. They said at the last is required to produce an angular acceleration of 2 revolutions per second square. Give attention, what is given? 2 revolutions per second square. It's not given 2 radian per second square, that's what SI system, 2 revolutions given. So in 1 revolution what is angle covered? 2 pi. So 2 pi, 2 into what? 2 pi, that's 4 pi. Now it become what? Radian per second square. This was revolutions per second was given. This is very important. You converting into what? Radian per second square. 4 pi is what your acceleration. So look here, that we understood. So now we need what? This tension, that becomes what? Inertia means what? 50 by 8. Alpha we found is 4 pi by radius. So radius is what? 0.5. Yes, so 1 by 2. This goes up. So you know this all get cancelled. Simply getting 50 into pi. Pi is around 3 point something. So 3 into 50 is around 150. Little more than 150 should be your answer. So what is the options given? 157 is given in what? Your fourth option. Okay, that's your answer. Okay, that was question number what? 14. Question number 15 also from 2014. Same year. Okay, and it says the ratio of the acceleration for a solid sphere rolling down an inclined plane without slipping and slipping down the inclined plane will be what? So solid sphere is given and they are asking ratio of the acceleration when is what? Rolling, and when is what? Slipping means sliding. Okay, solid sphere. First, what is the acceleration case of what? Rolling. Rolling is what? You know that is simply g sin theta upon 1 plus k square by r square. This is the case of rolling. Then sliding is what? In sliding this term is not there, so become will be g sin theta, right? This much only. So they are asking what's the ratio of these? Ratio to what they are asking? Rolling towards slipping. Means this by that they are asking. So acceleration of roll by acceleration of case of sliding or slipping, what it comes. Okay. So this by that they are asking, that term goes here. So simply it becomes 1 upon 1 plus k square by what? R square. So we need to put this k of this object which is given us what? Is given solid sphere. What is the inertia of solid sphere? 2 by 5 mr square. So you know k square becomes what? 2 by 5 and mr square. So this becomes 1 plus 1 by 2 by 5, 1 plus 7 by 5, 5 by 7. That will be your answer simply. First option is the correct answer in this question. Let's move on. So question number now 16. That's from AIPMT 2015. Okay. A mass m moves in a circle on a smooth horizontal plane with velocity v naught and radius r naught. The mass in the string is yes. The tension string is decreased gradually and circle moves in radius of what? R naught by 2, the final value of kinetic. This question actually repeated, exactly same question already we have answered. Let me tell you which question I have answered. Question number 8, exactly same question was asked about kinetic energy, radius is decreased. So I said that when radius is decreased, what not changing is what? Angular momentum. So kinetic energy writing in terms of angular momentum, L square upon 2I, right? Yes, inertia will be simply what? 2 mr square. So these all are constant. So energy and kinetic energy and radius are what? Inversely proportional. So here they say radius becomes half, energy becomes what? 4 times. So initial energy writing, suppose half m, which like this they writing initial, then final becomes what? 4 times of this. You multiply 4 times. So answer is given like this one, 2 m v naught square. That's your answer in terms of this formula given. And question number 8 they gave in terms of symbol only. They say simply said it becomes 4 times. Yes. So what is the answer in second option is correct here, 7. Question number 17 also from same year 2015, and a rod of weight W is supported by 2 parallel knives A's A and B, okay, and is in equilibrium on a horizontal position. The knives are at distance D from each other. The center of the mass of the rod is at distance X from what? A. The normal reaction on A will be what? So they are saying like this one, there is a rod, okay, say some length what? L, okay, and they are saying what is saying? 2 knives, where they are placed that we don't know, just you put anywhere. The one knife is suppose here, one knife is at this point, and this distance is given D, okay, simply let's call D that, okay. And they said the center of mass is what here, suppose the center of mass where you know mg will be acting. So this is your knife A, that's knife B, and what is given? and they said the center of mass of the rod is at distance of x from A. So that distance is given, suppose x, obviously that distance will be what, d minus x, right, d is the given between these two knife. I am putting at the both end. Okay. So question is this, that what is the normal reaction at what A? We have to calculate what normal reaction at A, means how much load shared by what A, how much load shared by what that knife B. So there will be a reaction here, reaction due to this will RA upward, due to this will like that one RB upward. So this is what under equilibrium they said, means net torque at any point should be what, 0. They are asking reaction at this point, means RA we need. So you take what, your torque at this point, B point, so that already I told you that the torque due to this force becomes what, 0. So you are taking torque about that point, B point. So I am writing net torque at B point should be what, 0. Let us write what are the torque at this point due to all the forces. So first torque due to this force RA, reaction RA, into what, perpendicular distance is what, from here to here, that becomes simply D. Okay. Then mg force minus we writing, because this force upward, that force downward, torque produced will be in opposite direction. Mg into distance is what, d minus x. Okay. Then this force RB into what, distance is what, 0, should be equal to what, 0. Okay, this term is completely 0. Then you see that we have to find this RA. So RA becomes simply what, mg d minus x upon what, d. That's your answer. Or you can write 1 minus d by x. So this is this much only given in what, third option. That's your answer. Quite simple. Okay. Okay. Let's move to question number 18. That also from same year, 2015. Okay. Okay. And in this question they are saying that three identical spherical shells, hollow spheres are given of each mass m and radius are placed as shown. We are considering an axis xx days which is touching the two shells and passing through diameter of the third shell. Moment of inertia about this system is what. So it's a very simple equation. We have done many questions like this in classroom. Three spheres are given, hollow spheres this given one, and this is the axis of rotation given, right. They are asking what is the net inertia. Okay, hollow sphere, first what is formula about center mass, 2 by 3 mr square. So look here, for this sphere, sphere 1, sphere 2, sphere 3, for this sphere this axis passing through the what, diameter itself, and for these two spheres is what, tangent, right, this and this is a tangent. So what is the net inertia, look here, due to this sphere 2 by 3 mr square done. Due to this sphere you have to write what, parallel axis theorem. So 2 by 3 mr square plus mr square, and you double it this, then both sphere. For this sphere also is a tangent, for this sphere also tangent, so I am just making double of this. So when you add them, I am just telling you, you can do it by yourself. So answer for this question comes what, 4 mr square. Okay. Question number 19 we are doing now. So it says that an automobile is there, it's moving with some speed given 54 km an hour. So velocity is given v, or let's call whatever u, 54. Directly I am converting into what, meter per second. So this becomes what, 15 meter per second, right? Yes. Then this says its radius is given, moment of inertia of the wheel about its axis of rotation is given 3 kg meter square. The wheel is brought to rest in 15 seconds. Then calculate the average torque transmitted. Okay. So this question is from what, AIPMT 2015. Again, repeat exam. It was cancelled this year. Okay. So we have to calculate torque. Okay. It's very simple. Torque is what, I into alpha, right? Inertia into what, angular acceleration. Inertia is given directly to you, 3 kg meter square. You just need to calculate what, acceleration, angular acceleration. Yes, you can calculate because initial velocity given, final is coming to 0 and time is given. But you need an angular format. Look, this is the initial velocity. Okay. So let's write omega naught. What is the answer? U by what, r, right? Linear velocity, you know, 15 meter per second. Mean the angular velocity is what, linear by what, radius. So 15 by how much radius given? Radius was given 0.45. So 0.45. So I can write this as how, 45 into 10 power minus 2. To simplify this I can do like 45 into 10 power minus 2. This goes 3 times. So I can write the answer as 100 by 3, right? Yes, 100 by 3, that is easier. And final is given 0 directly because coming to what, rest. So final angular velocity is what, 0. Time given, let's write equation, omega is equal to omega naught plus alpha into t. So alpha will be omega minus omega naught by t. Omega is 0 minus 100 by what, 3 by time, how much given? Time they gave us 15 seconds. Okay. Minus 100 by what, 45, right? Radian per second square. So this is your torque. Torque will be I into alpha. Inertia already given. Inertia they gave what, 3 kg meter square. 3 into what? Minus 100 by 45. This goes 15 times minus 100 by what? 15. So how the answer gave? 100 by 15 means how much? Cancel by 5, 20, 20 by 3. This got around 6 times. So around 6. So what option they gave here? Second option, 6.66 kg meter square per second square. That will be your torque. Okay. So it's a simple problem, not difficult at all. Question number 20 we are talking. Okay. Same year 2015 re-exam. So point masses M1 M2 are placed on the opposite ends of rigid rod of length L of negligible mass, and the rod is set to rotation about an axis perpendicular to it. The position of point P on the rod through which the axis should pass so that the work required to set the rod rotating with angular velocity is minimum. This is very important question actually, concept wise. They said I have a rod and this rod is rotating about some axis passing through this. They said that about what axis we should rotate this so that work done will be what? Minimum. Look here, understand first concept. You want work minimum, right? Rotational work minimum is work done is what? You know, torque into what? D theta, right? So you means what? Your torque should be what? Minimum. If you want to get minimum work, means your torque should be what? Minimum, right? And torque directly depends upon what? What is again torque formula? I into alpha, right? Torque is what? I into alpha. Means if you want to get torque minimum, means your inertia should be what? Minimum, right? You want work minimum, means torque should be minimum. You want torque minimum, means inertia should be minimum. And inertia you want minimum. And minimum inertia, I told you in last question, it happens what? When we are rotating about what? Center of the mass, right? This inertia will be minimum when body rotate about what? About what? Center of the mass. This I have explained right now. It means this rod should be rotated about what point? About center of the mass. So few things are given. Let me draw in picture. They said this is your mass M1, that's your mass M2, and this distance is given as x. Then that distance is given what? L minus x. L is the length of the rod. So they said where this axis should pass, means that x we have to calculate. Okay. So that work required to set this rod into motion or rotation will be what? Minimum. We want minimum work that directly depends on torque. Torque should be minimum. Torque directly depends again inertia. Inertia should be minimum. And minimum inertia happens when you rotate body about what point? About its center of the mass. About an axis which is passing through the center of the mass. Means this point is nothing but what? Center of the mass. Now let's go to center of mass chapter. You want to find that distance x. Okay. Let's take that coordinate as 0, 0 itself. Then what is the answer? Formula RCM, position of center of mass, what? M1 R1 plus M2 R2 upon M1 plus M2. Remember that formula? That one we are writing M1 into distance given what? With respect to this point, that distance will be negative, so minus x. This is the coordinate I am choosing here itself. This is your coordinate system. Okay, plus M2. Distance will become what? L minus x by M1 M2 should be equal to what? 0, because center of mass coordinate we are calling 0, 0. So look at this become how much? So this becomes minus M1x, and this becomes what? M2 into L minus M2 into x is equal to 0. So x you want to find, x becomes what? M2L by M1 plus M2. That will be your answer. So this answer is given in first option is given. Okay, that's all. So this is very important. Okay, work minimum is torque should be minimum. Torque minimum is your inertia should be minimum, and minimum inertia happens at what? When the body rotate about axis which is passing through the center of the mass of that body. Okay, let's move on. Question number 21 from the same year 2015. A force is given and acting at a point of this, the value of alpha for which angular momentum about the origin is conserved. Angular momentum is conserved. Very, very important again. Angular momentum is conserved means your torque should be what? 0, right? This is a principle we have learned. When the net external torque is 0, then angular momentum is what? Conserved. So they said we want to conserve angular momentum, means torque should be 0. So force given, distance given, just find torque and equate to 0. You will not, you will calculate your unknown thing. Something is given here like alpha. So torque is what? This is your torque. R cross what? Alpha. R cross F. So all are given. R is given 2I 6J minus 12K. This is your R given. Then cross product. F is given alpha I, this we have to find actually 3J and what? 6K. This is your force given. So they said momentum is conserved means torque should be what? 0. Net torque should be 0. Let's finding torque by R cross into F and make it equal to what? 0. So let's multiply this value. What comes? First you multiplying what? 2i. 2i and alpha becomes directly 0, right? I cross I becomes 0. So cycle, you know, I, j and k. You go like this one, you get positive answer. You go reverse, you get negative answer, right? Okay. So 2i and I is 0. Then I cross j means what? K. 2 into 3 becomes what? 6k, right? Okay. Then I cross what? K. I cross k is minus j. So 6 into 2 that becomes minus 12, right? And becomes what? J. I cross k. Okay. Okay. This term is done. Now let's go to this term. J cross what? I. J cross I means what? Minus k. And look here, minus 6 already there. So it becomes plus 6 alpha and what? K vector, right? So I multiplied j and what? I. J cross I minus k, 1 minus already given, 6 into alpha, so become positive. Then j into j, that becomes 0, j into k. So j cross k means becomes what? K, and how much given? Look here, minus 6 and here is what? 6, 36, and I said j cross k we doing, so positive answer comes, so minus 36 what? I. Okay. Okay, j also, this vector also done. Now k cross what? I. K cross I means become what? Positive j. So this minus 12 alpha and j will come, right? K cross I we did, k cross I, okay, j. Then k cross j, k cross j going reverse, so minus I will come. So look here, minus 12 and this is what? Plus 3, that becomes what? Total 36, right? I, and k cross k, that becomes 0, so this also done. So all this we have to make 0 because we are saying net torque is what? 0 to conserve what? Angular momentum. Okay. Look here. So this 36 positive, this 36 negative get cancelled, right? Okay. Then you see that these are two alpha terms, we take them separate and this is what? Separate. So this time taking like what is this? 6k minus 12j, we write it here. Alpha terms we take on other side. So when take other side, then what it becomes? It becomes like let's take alpha common, it becomes minus 6k plus 12j, right? So if you see that this you can also write as alpha, you take minus outside, then becomes 6k minus 12j. So this get cancelled here, right? So alpha is coming what? Minus 1. Right. So what is the main thing here? They said momentum is conserved, angular momentum is conserved means torque should be what? 0. So you wrote R cross F and made that term equal to what? 0. You found your unknown, right? Okay, now we are doing question from AIMS 2015. Question number we are doing is what? 22 now, and it says that the radius of a rotating sphere decreases by 2% keeping mass constant. What's the rate change in rotation? So it's the error problem, small error is given. So radius is reduced, angular momentum will not change. They are asking what happened to kinetic energy. So kinetic energy is what? L square upon what? 2I, we know, right? Correct. Simple. So angular momentum will not change. Oh yes, correct only. So okay, what is inertia? Let me write inertia also. So 2, and what is given this? Sphere given, any sphere doesn't matter. Let's write 2 by 5 m r square. Okay. So angular momentum not changing, this not changing, mass not changing. We know that energy proposed to what? R square, right now. Okay. So error writing, del E by E. Directly also you can answer if you understood this concept. R square means 2 times of del R by R into what? 100. This is given what? 2%. So answer becomes what? 4%. And radius is, they say, decrease. So means your energy should increase by what? 4%. But they gave only one option, just 4%. So what is the answer? Third option, correct answer here. Question number 23, also from AIMS 2015. What will the value of maximum acceleration of the truck in the forward direction so that the block kept on the brake does not topple? Toppling of the body, right? Torque concept, okay? So this is a body placed on truck is moving that direction. So force, pseudo force on this will apply in what? That direction, right? I should write like that direction, okay? Right. So actually, if you watch carefully, like pseudo force, we can write as acting through what? The middle point of the body, like in this direction, MA. This is your force applied, right? Body, this is placed on truck. I am not drawing whole picture. There is some truck given like that type. This truck is moving that direction. So pseudo force will act on that body in what? Opposite direction. Suppose acting through what? Center. Then other force acting is what? mg here. Suppose this topple about that point, means rotate and fall like that point, right? So we want to know that they say that what is the maximum acceleration, so that this does not topple, right? Maximum acceleration is what? So look here, let's write, suppose rotating about that point, so net torque should be what? 0, so that it doesn't rotate. So what is net torque? One force is what? m, and some dimensions are also given, right? So I think the height is given what? h, and this width is given what? A symbol, right, for this. So let's write net torque. Torque due to this ma force, so ma into perpendicular distance means what? About that point, this is a perpendicular distance, means h by what? 2, okay. And due to minus the mg force, mg and perpendicular distance will be that one, so that's what? A by what? 2. This just get cancelled. We have to find what? Acceleration. Acceleration becomes what? mm also get cancelled. Vg a by what? h. So let's check. So this is given actually in first option, right? Actually there was a problem in this question in that year. Some people say the answer is this much, and some people say the answer is what? Come divide by what? 2 here. Why? Because some people taking this ma force at top here, like this in here. Some people taking through what? Middle point ma. But okay, like this they did. So in this, because they did not that said this ma force acting at that point only, it should act through the middle point, okay, here. So answer should come whatever this answer only, okay. Let's move to question number 24, and this is from NEET 2016, okay. Form a disc of this is that type of question where you cut a part of the body and remove it, and then you have to find the new inertia. So said there is disc is there of radius r and mass m, a circular hole of diameter r. So there was disc given of radius r, okay, yes, mass m, and what we did, a circular hole of diameter r whose rim passes through the center is cut. What is the moment of inertia of the remaining part about an axis perpendicular and passing through center of mass? So this was the original disc, and they said a part of this is what? Cut and removed like this type. Diameter of this hole which is cut and removed is given 2r. Correct? No, sorry, r given, diameter given r, means radius is given what? R by 2. So it will touch on both, right? It will touch circumference here and center also, right? They will coincide. This is cut and removed. Then they are asking what's the inertia of the remaining part now. So look here, always I told you, first step is what? This is your y1 is your complete body, I2 is your second body's inertia, which is the part which is cut and removed. So always first find the mass of this body. So mass proportional to what area you can write? It's a two-dimensional body plate, and so mass of the whole disc we calling m, mass of this much part we calling m dash, area of the complete will be pi r square, area of this become pi r by 2 square, this become what? This becomes what? Simply 4. So m dash is what? M by 4. The mass of the part which is cut and removed will be m by 4. Now what is steps? First find the inertia of the complete disc, that we call what? I1. What is the inertia of the complete disc? Inertia formula is what? Mr square by 2. So mr square by 2. Mass of the big disc is what? M, radius is what? R by 2. This formula only done, equation 1. Now you want to calculate inertia of the removed part, means inertia of this disc about that point. So first you have to write what? Parallel axis theorem, because this is rotating about that point, we have to find inertia about that point. So inertia I2 equaling, which is inertia of the removed disc, okay. So what is inertia about center of mass here first? That formula is what? Mr square by 2 only, but m is what? M by 4, r is what? R by 2 by what? 2. This is the inertia about center of mass of this small disc about that point. M r square by 2, formula is that only, mr square by 2, but m for this small disc is what? M by 4, radius is what? R by 2, plus md square, m is what? M by 4, d, we need that distance, so that's what again? R by 2, right? So md square means R by 2 and what? Square. Okay, let's simplify this, then how much becomes? This become mr square, okay, this become 4, this become what? 16, that become what? 32 plus mr square, this become 4 become what? 16. 32 you take LCM, then you see this become 3 times of 32 and mr square, right? 32 goes 1 time, 16 goes 2 times, 3 times, okay. Hope I am doing calculations correctly only. Okay, I have key, so we will match the answer. So your inertia of the remaining part will be inertia I1, complete disk inertia mr square by 2. The inertia of the removed part, this becomes 3 by 32 of mr square. So 32 to take LCM, then this goes what 16 times, 16 minus 3 is what 13 by 32 of mr square. That should be answer. So let's see, does it match in any option? Yes, there is second option given, 13 by 32 mr square. That will be your correct answer. Okay, yes, that was question number 24. Okay, let's see next question. Question number 25, also from same year, NEET 2016. Question number 25. As uniform circular disc of radius given is at rest and free to turn about an axis which is perpendicular to its plane and passing through the center, it is subjected to torque which produces constant acceleration of about 2 radian per second square. Its net acceleration in meter per second square at the end of 2 seconds will be what? Few things are given to you. Is initial acceleration is given right now, and what we have to find is a final acceleration they are asking right now. Means net acceleration. Okay, look here. So what is given to us? Initial alpha given. Okay, so and initial what is given? Initially at rest is also given. So initial velocity is what 0 plus omega naught is what 0. This is clear, right now. They said it's 50 centimeter at rest, and time given, right? So you can find its final angular velocity. What is final angular velocity? Omega naught plus alpha into t. This time is 0 already. Alpha is what 2 given constant, and time is given what how much 2 second, right? Yes, this becomes what 4 radian per second. That is what your final angular velocity. If you know final angular velocity, then let's find is a centripetal acceleration AC. That we write omega square by r, but we know v square. We don't know v. You can write omega square into r. That also is your centripetal acceleration. So omega we know how much that final velocity 4. That becomes 16. And radius is given, I think, to us. Radius is given what 50 centimeter, means 1 by 2 meter. This becomes 8, correct na? So this is your what meter per second square. This is what your centripetal acceleration. Then if you want to calculate your linear acceleration, means tangential AT, you can write, we know alpha here, so you can write alpha into what r. Alpha already you know is 2, and r is what 50 centimeter is 1 by 2. That becomes what 1 meter per second square. So we know that in circular motion we have two acceleration. One is what your AC, one is what your AT. Net acceleration is what sum of these two. These two are at perpendicular. So writing that formula, vector addition root a square b square plus 2ab cos 90. So cos 90 term becomes 0. Simply a square b square. So means this square 8 square plus 1 square. That becomes what 64, 65. So almost is what 64 only. So answer is what almost 8 only, because in question itself they are saying that calculate the approximate answer. So it becomes what 8 only. Okay. Question number 26, also from same year to NEET 2016, and they said that a disc and a sphere of same radius but different mass roll off the two inclined planes of the same altitude and length. Which of the two will go to the plane first? So this question I discussed that if some objects are rolled from incline, then who will reach first to the ground? That depends on what time. So time, I told you time formula comes like this one. If you see, is 1 by sine theta something like 2h by g, right? Then 1 plus k square by r square, like this term is coming. So these things are constant for everyone. It depends only what this term, what term k square r square. So I told you that minimum value of k square r square, this minimum means that will come first to the ground. So here two objects are only given to us. What object given? Disc and sphere. Okay, disc. So disc inertia is what mr square by 2. So this formula, what formula will be that? K square by r square. So k means what? This is your k square. So it become r square by 2 by r square. That's become 1 by 2 or 0.5. That's for our disc. Then what given? Sphere, solid sphere. So solid sphere inertia is what? 2 by 5 mr square. So what will k square r square value? K square will be 2 by 5 r square upon r square. So it becomes 2 by 5 means 0.4. It means sphere will come first to the ground. Okay, solid sphere will come first to the ground, then disc. So this already I did nicely in theory. Hope you understand this. Problem number 27 we are doing now. A simple question is given. There said two bodies are given A and B, and okay, this question is from again NEET 2016, second time. Okay, there were two exams in that year. One exam was cancelled. So two bodies are given and there is a moment of inertia given, and they said they have equal kinetic energy. Rotational kinetic energy is given equal. Then how their moment of inertia related? So moment of inertia in terms of kinetic energy is what? Simply this formula 2I into E. If this is given same, then moment of inertia depends directly on angular moment directly depends on what? Inertia. So more the inertia, more the angular momentum. So they said in question that IB is more than IA. Inertia of second object is given more than, so same will happen, angular momentum B will be more than what? Angular momentum of the first object, because when kinetic is same they are proportional, right? So first option is the correct answer this question. Okay, next question also from 2016 NEET. So 28 question, and it says that a solid sphere of mass m in radius r is rotating about diameter, and solid cylinder of the same mass and same radius also rotating about geometrical axis with angular speed twice the sphere. The ratio of their kinetic energy of rotation will be what? So rotational kinetic energy of two things they are asking, one solid sphere and one is what? Solid cylinder. So let's write directly kinetic energy. First formula is what? Half I omega square. So we need these two things. So kinetic energy of solid sphere, then kinetic energy of what? Okay, I am writing a sphere, that's what? Cylinder. Both are given solid. Okay, I am not writing half will cancel, both will have same. Okay, still let's write half. Inertia of the sphere is 2 by 5 m r square omega square. Then they said angular speed of the cylinder is given double than the sphere. So what's the inertia of this? Half. Okay, half inertia becomes what? M r square by 2 for solid cylinder. Okay, and omega is given what? Double, so it becomes 4 omega square. So let's simplify this. M r square, these terms all get cancelled. Here goes 4 times and this get cancelled. We are getting I think 1 by 5. So yes, this is given an option and it's given in fourth option. Okay, simple question. Question number 29, and they're saying here the thin light rod of length L has two masses m1 m2 attached to its two ends. So one rod is given and two mass are here. Length given L is light rod, so mass of the rod is what? Negligible. Okay, moment of inertia of the system about axis perpendicular to the rod and passing through the center of mass is what? Center of mass they are saying, right? Again, this axis is passing through what? Center of mass of this system. So first what you can do, you can calculate center of mass. Center of mass already we calculated in some last question, that became like what? M2. If you calculate distance from here, suppose this x, then how much that x come? Like m2 upon m1 plus m2 into what? Total length L. This came answer right now. So this is what your distance. If you want to find now inertia, so you try like m into what? R square of this, right? But you forget like this way. There is another way to solve this type of question. This is called what? Reduced mass concept. This comes in 4-5 chapter. When you have two mass and you want to write them into single mass, you call reduced mass, like mu m something. This formula is what? M1 m2 upon what? M1 plus m2. This is called reduced mass. This comes in gravitation chapter, this comes in SHM chapter, it comes in many chapter actually. So we are learning reduced mass means two mass you are writing into single mass. This is the formula M1 M2 upon M1 plus M2. So this is total like one mass, and distance between them is how much given? That was given L, length of the rod. So inertia will be simply mr square. You can write reduced mass into what? R square. So this is what? M1 M2 upon what? M1 plus M2 into what? L square. That's called what? Your inertia. Two masses placed at some distance apart, then what's the inertia of that? Okay, so answer of this question number 29 will be Charlie. Third option is the correct answer. Moving to question number 30. Now, so these all questions were from NEET 2016, and now question we are doing from AIMS 2016. Okay, so here they are asking that there is a solid cylinder rolling from an incline angle is given 30 degree. They said find the angular velocity after it traveled what? 6 meter on the inclined plane. So some inclined plane is given. They said what is the angular velocity when it is traveled what? 6 meter. So this distance s is given what? That we call slant line 6 meter given, and they are asking angular velocity. Linear velocity formula we know. Let's first calculate linear velocity. What is linear velocity formula? Root 2g, this in terms of h, this s, this is what? Theta. Or you can write s into sine theta if you want to write in terms of this height by what? 1 plus k square by r square. This is what your linear speed. Let's calculate linear first. So what is formula? 2 g means 10, distance is given what? 6. This distance is given what? Inclined distance given, not vertical. Vertical means root 2 g h by that thing. Okay, sin theta means sin 31 by 2 divided by 1 plus k square, and this object is what? Solid cylinder. For solid cylinder, inertia is what? Mr square by 2. So your k square becomes what? R square by 2, means this formula becomes 1 plus 1 by 2, means this becomes simply 3 by 2. That's all, right? Okay, so let's see if you can cancel any number. Okay, 2 you can cancel here, 3 goes what? 2 times, and this 2 will go up, become 4. So velocity is coming root 40 meter per second. This is coming linear velocity. In this question they have asked us what? Angular velocity. So angular velocity omega is what? Omega is simply v by r, means root 40 by radius. Radius of this cylinder is given, how much given? 5 centimeter given. 5 into 10 power minus 2. Correct? So minus 2 goes up, become 100. 100 by 5 is what? Yes, correct only. This is 100 and this is 5, that's what? Root 40. This goes what? 20 times root 40. So how option is given? Okay, options given like this root 40. So here they wrote 4 into what? 10. This is the 4 into 10 they wrote, then 2 they took outside, so outside become 40 root 10. This is given option. Okay, this is given what? Second option. Okay, are moving now. So we are doing question number 31, which is from NEET 2017. NEET 2017. They said a rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. What's the angular acceleration of cylinder if the rope is pulled with a force of about 30 newtons? Similar problem we have done already. So this is a hollow cylinder, just remember that. Okay, and again rope is there and we pulling with the force given here. How much given? 30 newton. Radius given, mass given. They are asking what's the angular acceleration. So you know that this is a force, okay, F. This is the radius r. So torque produced by this force is what? F into what? R is also equal to I into alpha. We have to calculate alpha. So F into R by what? Inertia. All are given to us. Force is given 30 newton. Radius of this is given how much? Okay, force is given 30 newton. Radius is given 40 centimeter. 40 into what? 10 power minus 2. That's your F into R by inertia. So this is a what? Is a hollow cylinder, right? Sorry, what is given? Let me check. Question number 31. Yes, it's a hollow cylinder. Inertia is what? mr square, right? Okay, mass divided by inertia. Mass is given how much? Mass is given 3 kg and r square means what? 40 into 10 power minus 2 into 40 into 10 power minus 2. That's r square. 1 r you can cancel directly here. This goes what? 10 time here. 1 0 you can cancel here. So this is giving 100 by what? 4. 100 by 4 is also called what? 25. Yes, 25 radian per second square is given in option. That was question number 31 from 2017. Then next question from 2017 again, 32 problem. Is that problem that I told you, energy loss. So when one disk is rotating, you put another disk over this, then the loss of energy happens. So that formula, energy loss, is given by this formula I told you, half I1 I2 upon I1 plus I2 omega 1 minus omega 2 square. So this question is saying that two disks of same moment of inertia, I is given exactly same, I1 I2 are same, rotating about their regular axis, passing through the center and perpendicular to the plane of disk with angular velocities omega 1 and omega 2. They are brought in contact face to face, coinciding with the axis of rotation. The expression of the loss of energy in this. So just these are given equal. If you put equal, then what happens? I into I plus I. So this becomes what? Simply 1 by 4 into I and omega 1 minus omega 2 square. That answer comes here. So this is given in the first option itself. Very simple question. Moving to question number what? 33 from the same year 2017. Generally every year they ask 3 questions from what? This topic. Okay, rotation. This is a very important topic. Which of the following statement is correct? 4 statements are given and they are asking which is correct. First one, they said center of mass of the body always coincide with the center of the gravity. Always, no. In symmetrical bodies only the center of mass and center of gravity they coincide. Okay, so the first statement is what? Wrong. Center of mass of a body is the point where the total gravitational torque on the body is 0. Absolutely correct. At center of mass the total torque is 0. Yes, 0 always. Okay. So second statement is correct. Third statement, couple. Your torque is also called what? Couple. Torque is also called what? Couple. Okay. Couple because there are two force acting which make net your torque 0. Okay. So third statement talking, a couple on the body produces both translatory and rotation motion in a body. Means they are asking like your couple means torque will produce translatory and rotation both motion. Torque will produce only what? Rotational motion, not translatory. Okay, so this is wrong, means your C statement is wrong. Then fourth, mechanical advantage greater than 1 means the small effort can be used to lift a load. Yes, that's simple, everyone know, you learn in junior class also, mechanical advantage. So first and what? Delta, no, second and fourth options are correct. It means fourth option is correct here. Second statement B and statement what? D, these are two correct. So fourth option is what matching here. So this was 33 from 2017. Now AIMS 2017 AIMS problem. Okay, yes, what is problem? The problem number 34, the saying, find the moment of inertia of a uniform annular disc, they are saying, of mass given 100 gram, inner radius given 10 centimeter, outer radius given 20 centimeter. So annular disc rotating about what? This point, axis perpendicular to the plane. What is formula of annular disc? M by 2 of R1 square plus R2 square, right? All are given. Mass is given 100 gram into 10 power minus 7 is 0.1 kg by 2. Radius first is given what? 10 centimeter, second is given 20 centimeter. 10 centimeter means 100, 20 means what? 20 means what? 400 and 10 power minus 4 outside. Centimeter is given, okay? Yes. Okay, this become 500, right? 500 means 1 become 50, 50 means become 25 into 10 power what? Minus 4. So that should be answer. Yes, this is given first option. How they wrote? 2.5 into 10 power minus 3. That's given answer. First option. Question number 35 we are doing. We are doing now question from NEET 2018. NEET 2018 problems we are doing. So question number 35 says that three objects are given: solid sphere, a thin circular disc, and a circular ring. So sphere given, disc given and ring given, each of the same mass and radius r. They all spin with the same angular velocity omega about their own symmetry axis. The amount of work required to bring them to the rest will satisfy which relation? So three things are rotating with same angular velocity. What? A solid sphere, the ring and a disc of same mass and same radius. We want to stop them. Then in which case you have to do maximum work. So work done is actually what? Change in what? Your rotational kinetic energy, right? Initial rotational kinetic energy is what? Like they are rotating at some velocity. That's we call half your I omega square. This is your right, and they are rotating with some this kinetic energy, and you want to stop them means you want to make final as 0, right now. So work done simply what? Final minus initial means work done depends on this term, right now, your initial rotational kinetic energy. So omega is given same for everyone. So work done directly depends on what? Inertia, right? So whose inertia is maximum? Look, your ring is what? Ring is what? mr square. Disc is what? 2 mr square by 2, and solid sphere is what? 2 by 3 of mr square. So ring has the maximum inertia, right, for the given mass and radius, right? Mass and radius are all are given equal, omega also given equal. So inertia of the ring is maximum. So maximum work done will be in case of ring, then your disc, then what? Your sphere. So maximum work in case of C, B and means first option is what? Correct here. Question number 35. Let's move to question number now 36. And here they said the moment of force. Force is given. This question also from NEET 2018. Okay. This year they asked 4 questions. Okay, from this topic. Very important. Okay. So moment of force given, and is force is acting at this coordinate 2, 0, 3, and you have to find torque about 2, minus 2 this point. Okay. Yes. Okay. So first, where is force acting? I gave stress on this point that people do wrong here. Force is acting at this point, and torque we have to find about what point? Torque we have to find about this point 2, minus 2, right? So proper distance you write, always start from force and go to what? Torque point where you want to find torque. So how you write R here? R will be 2 minus 2, that becomes 0I. 0 minus that becomes what? Plus 2J. Minus 3 minus becomes what? Minus K, right? Minus 3 minus become plus. Okay, so R is coming simply what? 2j minus k. That's your r coordinate, right? And force is given directly to you, so let's find. So torque will be what? R cross what? F. Let's find. R is given 2j minus k. 2j minus k cross product with force. So force is given 4i 5j minus what? 6k. So let's multiply this number and check what happens. So torque will be how much? Okay, cross multiplication, you know, I, j, k, this goes, right? Clockwise means what? Positive answer, anti-clockwise is what? Negative answer, right? Okay, first writing j cross what? I. J cross what? I become minus k. So this become 8 minus k, right now? Yes. Okay, j cross j becomes 0. J cross k. J cross k becomes what? Plus I. So that is given what? Look here. First look here. 2 and this become minus 12. Okay, so minus 12 and I. Okay, that's j term is done. K cross I, that becomes j. So how much becomes? Minus 4j, right? Okay, then k cross j means minus I, and one minus already there, so it become what? Plus 5i. K cross k becomes 0, so this much only. So let's arrange this. Minus 12i minus 5i, that becomes what? Minus 7i. Then minus 4j, then minus 8k, that is your torque. So let's check. This is matching what? Minus 7i, minus 4j, minus 8k. That's matching in your fourth option. Fourth option is correct here. Okay, so it's important, force and torque. So start from force, go to here. So this minus that, you have to write proper distance. Question number 37 now we are talking, and also from same year, NEET 2018. A solid sphere is in rolling motion. In rolling motion, it possesses translatory kinetic energy as well rotational kinetic energy. Right? The ratio of the total to what? Sorry, KT. K means what? Rotational. Sorry, translatory. So they are asking simply what's the ratio of the translatory kinetic energy to what? Total kinetic energy. Means what? Half mv square upon half mv square plus half I omega square. This is more simple, half mv square. This you can also write as what? Half mv square. I told you shortcut 1k square by what? R square. Okay, this goes here. So this much only remaining. What? This ratio becomes 1 upon 1 plus k square by R square, and this object is given what? Solid sphere. Inertia formula solid sphere is what? 2 by 5 mr square. Means k square is what? That term 2 by 5 r square. 1 upon 1 plus 2 by 5, that become 1 upon 7 by 5 or 5 by what? 7. That's your answer, which is given what? Second option. Question number 38 we are talking now, and it says solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increased keeping its mass same. Which of the following physical quantity will remains constant? What is remains conserved? Angular momentum. Right, so what is the answer of question number 38? Angular momentum. Okay, yes, like do not confuse rotational kinetic energy. Mechanical energy is conserved, okay, not just rotational. Okay, so question number 38 correct answer is what? Fourth option. Then okay, these four questions were from NEET 2018. Now I am doing question from EMS. Okay, EMS. So the question number 39 EMS 2018 problems. Okay, yes. So look here, first question given 39, they said there is a tractor belt moving over two wheels like this way. Okay, you have seen. Okay, and what is given? Velocity is given what? V. So the tractor is moving with a velocity of 6 km per hour. Velocity is given 6 km an hour. Then what else given? The mass of the belt is given, which is given 720 gram. What is the kinetic energy of this belt? They are just asking kinetic energy. So it's important to understand here what. Look here. This is, suppose we assuming this is doing pure rolling, right now. Then pure rolling, what happens? The velocity of this is given v. So velocity of the top belt will be, and top this top point, at top point the velocity of the net velocity becomes what? Double of the center of mass, right? This is the velocity of center of mass v is given to us, and at bottom point the velocity becomes what? 0. This we learned at the starting of the pure rolling. What is the definition of pure rolling? The velocity at point of contact is what? 0. So this one belt is at ground, you know, right? And other belt is what? On the top. So velocity of this belt is what? 2v. Velocity of that belt at bottom will be 0. So kinetic energy due to this belt will be first 0 directly, right? Yes, no kinetic energy due to this lower part, kinetic energy will be 0 because this net velocity is what, 0. Then what is the kinetic energy due to the top belt? So kinetic energy is what, formula is what, half mv square, half mv square mass. Total mass was given this much. So half mass of the top belt and half mass for the bottom belt. So mass will not put 720 gram. Half of this only you have to put because half belt which is on top, that's moving. So 720 gram is 10 power minus 3 and divide by 2. This m. Then what, v square. So velocity is given 2v. So that becomes 4 times of v square, right? So what is the velocity? So velocity is 6 km an hour. 6 into what, 5 by 18. This go 3 times, so 5 by 3. So 5 by means 20, 5 by what, 9. This is the number. Okay, let's simplify this. 4 goes here. Okay. So if you write this decimal, this becomes 7.2. So 25 by 9, 7.2 become around 20 by 9. So what are the options given? This become around 20. Little less than 20. So answer nearly equal to what, 2. Yes, in option they gave 4, 1, 2. They gave very, very clear options. So answer should be what, 2 joule. That's all when you multiply this number. Yes, the M's question little confusing. Last problem is what, 40 problem. So they said here an elevator initially at rest. Again M's problem only, 2018. So an elevator is initially at rest, is supported by a cable, passes over a pulley of radius 0.4 meter. It is accelerated upward with 0.6 acceleration. Find the number of rotations made by the pulley during first 10 seconds. Okay. So look here. What is given to you? They said elevator is initially at rest. Initial velocity is given 0. Correct. Then pulley radius is given 0.4 meter. Is accelerated. Acceleration is given what? 6. So 0.6 meter per second square. Find the number of rotations made in what, 10 seconds. Time given, we have to find number of rotations, right? You can solve this in terms of angular, you can solve this in linear also. I do by linear. Look here, more simple. Let's calculate what is total distance traveled. S will be what, ut plus half at square. I know these things. This is 0. Initial velocity given 0. So S becomes half, acceleration given to me 0.6 and time given 10, 10 into what, 10, this becomes 0.3 and 1 0 goes 30 meter. That's the distance traveled, right? They are asking number of rotations. So you know that in one rotation in linear we say total distance traveled is 2 pi r, right? And if you multiply number of rotations, then you can calculate total distance, which is given already what, 30 meter. We have to find number of rotation, that becomes 30 upon 2 pi into r. Radius is already given to us. Radius is given of 0.4 meter. So 0.4 meter, 30 by, this become what, 0.8 into, yes, into pi, right? So how much it comes? Pi means 3 points, almost goes 10 times 10 upon 8. So answer become little more than 10. So what is answer given? Little more than, that's what given, 11.94 number of the turn. I have solved this question using what? Just linear motion. You can solve using angular also. Just write angular velocity, angular acceleration, then you find theta, your number of rotations, what, total angle covered by what, 2 pi. But here it becomes a little difficult. So linear itself is coming what, easy to solve this, okay? Yes. So this is, these are the previous year questions. If you still have any doubt, please put your comment, okay? Thank you so much.